The National Electrical Code does not apply to telecommunications cables. However, industry standards and best practices recommend using pullboxes sized according to the number of cables and connectors. Downsizing pullboxes may compromise cable management, increase cable stress, and make it difficult to pull new cables in the future. There are alternative solutions you should consider. Firstly, negotiate space and request more space in the shaft for the pullboxes. Secondly, consider smaller cables and use cables with a smaller diameter or more compact connectors. Thirdly, use expansion pullboxes and install pullboxes that can be expanded as needed to accommodate increased cable count. Fourthly, utilize additional pullboxes and install smaller pullboxes at each floor and additional pullboxes in the shaft to provide flexibility and reduce overcrowding. Other considerations to keep in mind are to consult with a qualified telecommunications engineer for guidance. Local building codes may have specific requirements for pullboxes in existing shafts. Consider future expansion and maintenance requirements when sizing pullboxes. While downsizing pullboxes is not recommended, it may be necessary in certain circumstances. However, it is crucial to carefully consider the potential consequences and implement alternative solutions to ensure proper cable management and future accessibility. Cable management is crucial for maintaining a functional and organized telecommunications system within a building. When dealing with a telecom riser in an existing shaft as described, several factors must be considered to ensure proper cable installation, accessibility, and future expansion capabilities. Firstly, understanding the role of pullboxes is essential. Pullboxes serve as intermediate access points within a conduit system, allowing for easier cable pulling, splicing, and routing. They are typically strategically placed along long cable runs or at points where cables change direction significantly. Their size and placement are governed by industry standards and best practices to ensure that cables are not subjected to excessive stress during installation or maintenance. Secondly, industry standards dictate that pullbox sizing should be determined by the number and size of cables passing through the box, as well as the bending radius requirements of the cables. The National Electrical Code, or NEC, which primarily governs electrical installations, does not directly apply to telecommunications cabling. However, it is important to adhere to recognized industry standards and best practices for telecommunications cabling installations to ensure safety, reliability, and future expandability. When faced with a situation where standard-sized pullboxes do not fit within the existing shaft, several alternative solutions should be explored. One option is to negotiate for additional space within the shaft. This may involve coordinating with building management or other stakeholders to reallocate space or modify the shaft to accommodate larger pullboxes. If obtaining additional space is not feasible, the next step is to consider using smaller diameter cables or connectors. Advances in cable technology have led to the development of cables with reduced diameters without compromising performance. Similarly, compact connectors can minimize the space required for cable terminations within the pullbox. Another approach is to utilize expansion pullboxes. These specialized pullboxes are designed with modular components that allow for easy expansion as needed to accommodate increased cable counts in the future. They provide flexibility and scalability while minimizing the initial space requirements. In situations where space is severely limited, it may be necessary to install multiple smaller pullboxes strategically throughout the shaft. By distributing the cable load among several smaller boxes, the overall space requirements can be reduced while still maintaining proper cable management and accessibility. In addition to these alternative solutions, it is crucial to consult with a qualified telecommunications engineer for expert guidance. A telecommunications engineer can assess the specific requirements of the installation, evaluate the available space, and recommend the most appropriate pullbox sizing and placement strategy. They can also ensure compliance with any local building codes or regulations that may apply to telecommunications cabling installations. Local building codes may contain specific requirements for pullboxes in existing shafts. It is essential to research and comply with these codes to avoid potential violations or safety hazards. These codes may address issues such as fire resistance, ventilation, and accessibility for maintenance personnel. When sizing pullboxes, it is important to consider not only the current cable count but also the potential for future expansion. Telecommunications infrastructure is constantly evolving, and it is likely that additional cables will need to be installed in the future to support new technologies or increase bandwidth demands. Therefore, it is prudent to oversize pullboxes slightly to accommodate future growth. Proper cable management within pullboxes is essential for maintaining a neat, organized, and accessible cabling system. Cables should be neatly bundled and secured within the box to prevent tangling or damage. Adequate slack should be provided to allow for easy cable movement and maintenance. In conclusion, while downsizing pullboxes may seem like a viable solution when space is limited, it is important to carefully consider the potential consequences and explore alternative solutions. By negotiating for additional space, using smaller cables or connectors, utilizing expansion pullboxes, installing multiple smaller boxes, consulting with a telecommunications engineer, complying with local building codes, and considering future expansion needs, it is possible to create a well-designed and properly functioning telecommunications riser system that meets the current and future needs of the building. Moreover, it's prudent to document the installation thoroughly. Detailed records of cable routes, pullbox locations, and cable assignment should be maintained for future reference. This documentation will be invaluable for troubleshooting, maintenance, and future expansion projects. Regular inspections of pullboxes and cabling should be conducted to identify any potential issues, such as loose connections, damaged cables, or excessive cable stress. These inspections can help prevent costly downtime and ensure the continued reliability of the telecommunications system. Consider the environmental conditions within the shaft when selecting pullboxes and cabling materials. Factors such as temperature, humidity, and exposure to chemicals can affect the performance and longevity of telecommunications equipment. Choose materials that are resistant to these environmental factors to ensure long-term reliability. Where practical, implement cable management techniques such as color coding or labeling to facilitate identification and troubleshooting. These techniques can save time and effort when performing maintenance or making changes to the cabling system. Ensure that pullboxes are easily accessible for maintenance personnel. Avoid placing obstructions in front of pullboxes that could hinder access. Also, provide adequate lighting within the shaft to facilitate visual inspection and maintenance tasks. Proper grounding and bonding of pullboxes and cabling are essential for preventing electrical hazards and ensuring the integrity of the telecommunications system. Follow industry standards and best practices for grounding and bonding to minimize the risk of electrical shock or interference. Consider the impact of cable weight on the structural integrity of the shaft. Overloading the shaft with excessive cabling can compromise its structural stability. Consult with a structural engineer to ensure that the shaft can safely support the weight of the telecommunications infrastructure. Prioritize safety when working within the shaft. Use appropriate personal protective equipment, such as hard hats, safety glasses, and gloves. Follow established safety procedures for working in confined spaces and around electrical hazards. Keep in mind that the telecommunications industry is constantly evolving, with new technologies and standards emerging regularly. Stay informed about the latest developments in cabling and pullbox technology to ensure that the telecommunications infrastructure remains up to date and capable of supporting future bandwidth demands. Consider the aesthetic impact of the telecommunications riser on the overall appearance of the building. While functionality is paramount, it is also important to strive for a clean and organized installation that minimizes visual clutter. Conceal cabling and pullboxes where possible to maintain a professional appearance. When selecting pullboxes, consider the ease of installation and maintenance. Choose pullboxes that are designed for easy access and cable routing. Also, consider the availability of replacement parts and technical support. In summary, designing and installing a telecommunications riser in an existing shaft requires careful planning, attention to detail, and a thorough understanding of industry standards and best practices. By considering the factors outlined above, it is possible to create a reliable, scalable, and well-managed telecommunications system that meets the current and future needs of the building. Remember to always prioritize safety and consult with qualified professionals when necessary. The following is additional information regarding NEC 314.28, which covers pull and junction box sizes for conductors 600 volts or less. This section provides the rules for calculating the minimum size of pull and junction boxes based on the size and number of conductors entering and exiting the box. The calculations differ depending on whether the conductors are straight pulls or angle/U pulls. For straight pulls, where conductors enter one side of the box and exit directly opposite, the minimum length of the box must be at least 8 times the trade size of the largest raceway entering the box. For example, if the largest raceway entering the box is 4-inch conduit, the box must be at least 32 inches long, which is 8 times 4. For angle or U pulls, where conductors enter and exit the box at an angle of 90 degrees or more, the calculation is more complex. The distance between the raceway enters and closing the same conductor must not be less than 6 times the trade diameter of the largest raceway plus the sum of the diameters of all other raceways on the same wall and row. When calculating the minimum dimensions for angle or U pulls, all raceways entering the same wall and row must be considered. The distance between raceway entries must be sufficient to accommodate the bending radius of the conductors without exceeding the maximum fill requirements of the raceways. The NEC also specifies minimum wire bending space at terminals, as outlined in section 312.6. This section provides requirements for the amount of space needed to bend conductors at terminals within enclosures, such as panel boards and switchboards. The bending space requirements vary depending on the size and insulation type of the conductors. The goal is to ensure that conductors can be properly terminated without undue stress or damage. In addition to these general rules, the NEC also includes specific requirements for pull and junction boxes installed in specific locations or applications. For example, Section 314.27 provides requirements for boxes installed in wet locations, while Section 314.29 covers boxes installed in hazardous locations. When selecting and installing pull and junction boxes, it is important to carefully review the NEC requirements to ensure compliance with applicable codes and standards. Failure to comply with these requirements can result in safety hazards, electrical problems, and code violations. The proper sizing and installation of pull and junction boxes are essential for ensuring the safety and reliability of electrical systems. By following the NEC requirements and industry best practices, electricians and installers can minimize the risk of electrical hazards and ensure that electrical systems operate safely and efficiently. Keep in mind this is primarily for electrical, not necessarily telecom.